last year. Hopefully you at least remember hearing the word. So, a logarithm is written y equals log base a of x. That a is a subscript, that's the base. And it can be written, it's another way of writing things from exponential notation. Just like when we were talking about exponentials, the base has to be a positive number other than 1. So we can go back and forth between exponentials and logs. The base of the log is the base of the exponential. And so it's like going across the equal sign. It means a to the y power equals x. So the base is the same if you write it in exponential. So log base a of x is equal to y. The a has to be a positive number. So does the x, because remember from our graphs, we're talking about the exponentials last week. If you take a positive number to a power, you get a positive answer, right? So x is that answer after doing an exponent, so it has to be positive as well. So let's look at this. If I want to write this as a logarithm, we're used to seeing these exponentials. If I want it as a log, your base of the log is the base of the exponential. So what was the base of this? So we write that as a subscript. So it's log base 1.2. Think of it as going across this equal sign of m is equal to 3. So the answer to that log problem is your exponent. Second one, log. What's the base this time? E. Of 9 equals Can we go the other way if I give you the log? Can you tell me the exponential? So if I said log base a of 4 equals 5. So, as an exponential, this would be what's my base? A to the 5th power equals 4. How would I write B? So we need to be able to go back and forth between exponential and log notation. Any questions there? I want to practice evaluating some logs. And there's really 2 ways of doing it. If you understand what the log means, you might be able to look at this and tell me the answer. When I say log base 2 of 16, I told you the answer to a log problem is the exponent. What this means is 2 to what power equals 16? 4. Okay, if you don't see that, you could write it as an equation. You could say, okay, that equals x. So if you wanted to change it to exponential form, it would be 2 to the x power equals 16. Didn't we solve problems like this last week? We got a common base. So 16 is 2 to the 4th. So x is 4. The first two questions on the homework tonight have multiple parts, but they're asking you to evaluate these. So if you know what they mean, it's not necessarily a lot of work. If I said log base 2 of 8, what would that be? 3, because it means 2 to what power equals 8. If I said log base 3 of 9, 2, 3 to the second is equal to 9. If I said log base 5 of 125, 3. 5 to the third is 125. Do you guys understand how I'm evaluating those? So what if I said log base 3 of 1 over 27? A negative exponent puts it on the bottom. 3 to what power equals 27? Alright, see if you can write down the answers for C and D for me. If you can't just look at it and know the answer, that's okay. Set it equal to x and treat it like an equation. If you did that, it means 2 to the x equals 1. 1 is the same as 2 to what power? 0. So x equals 0. Or you could have said 2 to what power equals 1? So 0. This means 5 to what power equals 25? 2. Alright, so equations, if you get stuck, but sometimes you might be able to look at them and write down the answer there. So the answer to a log is the exponent. Any questions about that? Second piece I want to talk about today is what the graph of a log looks like. So what I want to do is compare it to an exponential. We are going to graph y equals 2 to the x and y equals log base 2 of x and compare them. Okay, we graphed exponentials last week. You guys remember how we did that? We put in 3 points, -1, 0, and 1. So if I'm graphing 2 to the x, what's 2 to the -1? What's 2 to the 0? And what's 2 to the first? So we have -1, 1 half, 0, 1, 1, 2. And when we graph these, do they ever hit the x-axis? No, remember that was our horizontal axis. What's the domain of that? What's the range? The second thing I asked you to graph was y equals log base 2 of x. It can be helpful if you think about that as an exponential. How would I write that in exponential form? 2 to the y equals x. So it's really just graphing another exponential. When we graphed exponentials, we put in -1, 0, and 1 for the exponent. Which variable is my exponent? The y. So I'm going to put in -1, 0, and 1 for the y. So 2 to the -1, 2 to the 0, and 2 to the first. Do these points look familiar? What happened to them? X and y flipped. Okay, let's graph them. So we have 1 half, 0, 2, 1. Okay, will I ever get 0 out as an answer for my x? No. So what kind of asymptote does this one have? Yeah, this has a vertical asymptote. What do we call these? They are inverses. Exponentials and logs are inverses. We see that because the x and y flipped. The domain of the log is the 0 to infinity. It was the range of the original, but the range of a log is infinity past infinity. So, exponentials have a horizontal asymptote, logs have a vertical asymptote. They're opposites. All you're doing is reversing your x's and y's. So let's make ourselves a little note here of what we just found. The log is the inverse of the exponent. So what we're going to do now is a couple examples of graphing these logs and make sure that we're okay with that. Any questions so far? I want to start with just a couple basic ones before we do any transformations or anything. So if my function is f of x equals log base 1/3 of x. To graph these, we usually make t-charts. I strongly recommend you rewrite it as an exponential before you do that. So as an exponential, this would be 1/3. F of x is the same as what variable? Equals x. So which variable are you going to plug in your numbers for? The y, because it's the exponent. So -1, 0, and 1. Okay, what's 1/3 to the -1? 1/3 to the 0. And 1/3 to the first? 1/3. So my points. -1, 1, 0, and 1/3. Where does this one have an asymptote? Vertical asymptote. You can do more points if you need to. It is curving here. So something like that. I want you guys to try f of x equals log base 5 of x. So in exponential form, it would be 5 to the y power equals x. So put in -1, 0, and 1 for your y. So 5 to the -1 is 1/5. 5 to the 0 is 1. 5 to the first is 5. So we have 1/5, -1, 1, 0, 5, 1. And it should look like this. Are we doing okay with this? Just like when we graphed exponentials, if I put anything else with it, we did a parent function and transformation, so we're going to do that for the logs as well. So let's graph these and give the domain a So for this one, what would be my parent function? Exponential, that means 3 to the y power equals x. Put in -1, 0, and 1 for the y. So 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. That's our parent function. So we'll do that one dashed. What's my transformation here? Left 2. If I move this entire graph left, what else is going to move? The asymptote. The vertical asymptote was at 0. So when we go left 2, it's now at -2. So with exponentials, if we move them up or down, it moves the exponential. With the logs, if we move left or right, it moves that x one. So what is the domain? Starts at -2, goes to infinity. Range, we have one end going down forever, one going up forever, so the range infinity cos infinity. Alright, you guys try B. Graph the parent function and your transformation. And the range? Do we need more practice with this stuff? Okay. Where I'm stopping today, so 1 and 2, 4 through 10 even, so 4, 6, 8, and 10. A lot of these questions are matching, so they should go fairly quickly. I think there's like 3 that you are actually drawing a graph on.